Hey engineers, this is Mr. Hernandez, and in this lesson, we're going to learn how to take our control of the robot one step further, and we're actually going to teach it how to make its own choices. So hopefully we can program this carefully and the robots won't go crazy and try and take over the world. Let's go ahead and take a look at the assignment and what exactly you're going to be doing. So this is called VEX Robotics number 6, and we're going to introduce a new sensor and some new concepts. So last time we introduced the bump sensor, which basically does what it says. It detects whether the robot bumps into stuff. This time we're introducing the color sensor, and this one's a little bit different. So the color sensor can basically measure light, and that lets it detect the color of whatever it's pointed at. And it can do a little bit more than that too. Now the robot has two color sensors. There's one that's pointed forward, and in the program that's named front eye, and there's one that's pointed downwards, and in the program or in the blocks that's named down eye. So we can take a look at things that are in front of it and things that are below it. Now, the color sensor is a little bit more capable than the bump sensor, so it actually has a few different reporter blocks. So you can see here, all three of these blocks here are reporter blocks for the eye or for the color sensor. So we can use it in three different ways. So the first option is called near object. This one is a Boolean. That's why it has those points on the end. So it only reports true or false. So this one will say true if there's something in front of it, and false if there's nothing in front of it. Interesting thing about that, the down eye will always say true because there should always be a ground right below it. Now the color sensor doesn't have a huge range, so it's only going to report things as true if they're very close to it. The next option is a detect color Boolean block. So this one will give you two options. So you can decide which eye you're using, the front or down. And you can also decide which color it's detecting. So for example, with this image right here, if the robot drives up to something that is red, then this will report true. But unlike the bump sensor, if this drives up to something that is green, it's still going to say false. It's not reporting if there's something there, it's reporting if the thing is the right color. So it's a little bit more complicated, but it also gives us some more control. The last one is not a Boolean. This one's an oval shape. It's still a reporter block, it's just not a Boolean. This one will give you the brightness. So it's going to give you a percentage, a number between 0 and 100, depending on how bright it is. We're not going to use that one at all. We're only going to be using, in fact, for this one, we're almost entirely going to be using detects color. So let's go and take a look at the new maze as well. You guys can answer these questions on your own time. But down here, I'm going to take a look at these instructions. So you're going to go to VEX Code VR. You're going to open the playground and switch to disk maze. Then you're going to clear out any old code blocks you still have on the workspace. So this is the top view. This is what your playground is going to look like when you get it there. So in VEX Code VR, so I've got the playground open. Right now it's on the wall maze, but we need it to be on disk maze. And while that's loading, let's go ahead and clear out the old code blocks. Now, if you're wondering why it's called disk maze when it looks like it has like weird rectangles all over the place, we can change the view right here. And if we go to the robot's perspective, you can see that those rectangles actually have these like frisbee shaped disks in front of them. That's why it's called the disk maze. You can see it a little bit better like this. So each of those has both a rectangle on the ground and this little stand with a like frisbee shaped disc on it. There's also a couple of rules that we have to follow here. So in the disk maze, green means to turn right, blue means to turn left, and red means to stop. You can see that there's only one red block here. The rest of it's all green and blue. We're gonna have to figure out how to get the robot to navigate through this maze properly. So we're gonna start with program 1. And in this one, we're only going to use stack blocks and wait until blocks. And we're going to use these to write a program that will take the robot through its first 4 turns. This is similar to the approach that we use for the bump sensor on the wall maze. So just like that one, doesn't matter how far away anything is, we're using the sensors instead of the distances. So that means that we're going to be using drive forward instead of drive forward 4 blocks. First question, which sensor should the robot use, the front eye or the down eye? Well, to figure that out, let's start with a test program. So we're going to have drive forward, and then we're going to get a wait until block. And then for the Boolean, we're going to use front eye detects color. And then this isn't a block we've really used, but we're just going to use it right now to test things. I'm going to use the stop driving block. So if this works correctly, the robot will drive forward until the front eye detects a color, and if it detects that color, it's going to stop driving. Now, to make this a fair test, we can see what color is in front of it. It's going to be green, so I'm going to set this to green. So if the front eye is working, then it should stop once it gets there. Let's see. Drives forward, and it detects the green disc at the front. You can actually see the color sensor right there. All right, let's reset, and let's try the down eye. So this is the eye that's on the bottom of the robot. I'm not sure if I can show it to you. No, it's actually right there facing directly downwards. So if this works, then it'll also drive forward until it detects green, and then it'll stop. So let's see if it can detect that green on the floor. Okay, and it does. So that means that you can actually use either of them. You probably want to be consistent with whichever one you use because they can be a little bit different, but you're free to use either the front eye or the down eye for this. I'm going to use the front eye, honestly, just because it's the default, and that means I don't need to switch it when I drag it out. All right, so there's our setup, and now we need to figure this out. So what is the first color the robot will see? We've already answered that is green. What direction should it turn once it gets there? Well, remember our rules up here. Green means it needs to turn right. So to answer the code blocks part, we can substitute in. So we have this set to green, and then we can also have our turn right block. And then we take our screenshot of those two code blocks. So you can do the same thing for question 5, which says, what is the second color the robot will see? So if you're not sure, you can try this out. So we're going to add this here. So it's going to drive forward, detect green, turn right, drive forward again. So forward, turn right, forward again. Okay, so we can see what color it hits next, and it is blue. Now the last question is a little bit tricky. I want you to try and trace out the path that the robot's going to take and figure out how many steps it's going to take the robot to get to the red square. So this whole section, driving forward and detecting green, that's one step. Once it detects blue and does what it's supposed to do there, that's going to be the next step. So right here, let's actually, just to see what it's going to do, let's build the next part here. Now, every step here is going to be the same 3 blocks. So you can actually just plan ahead and start duplicating them. So we know that the second color is going to be blue, and then it needs to drive forward again. Remember, blue means turn left. So let's see where it's going to go here. So there is step 1, turns. There's step 2, turns. Step 3 is going to hit this next blue one. And remember, you have to program all the way up to step 4. So we've got 2 steps here. You're going to add the next 2 for this program. But also, think about this question. How many steps is it going to take to get to the red square here? You don't have to program all of this, but you can kind of plan it out. So step 1 takes it to green, then it turns right. Step 2 takes it to blue, then it turns left. Step 3 takes it to blue, then it turns left. Step 4 takes it to blue, then it turns left. Step 5 takes it to blue and it turns left. And then step 6 takes it to green and it turns right. So that's most of the steps. You can fill in the rest on your own. Same way I did, just trace out the path that it's probably going to take. Do your best for this one. Like I said, you don't need to program it to go all the way through. You just need the first 4. And I'll give you a hint here. Your program should be about that long. If it's longer than that, you're doing too much, and you can just pause right there and go back. Because I don't want you guys to spend too much time on this because you've got 2 more programs to write. That said, I think I've given you enough information to finish that, to answer this question. Don't forget to take your screenshots here, and let's go on to the next part. That's right, we've got a second set of new blocks and concepts. So we're going to use the repeat forever block. We've actually used this for the stars already, but it's making a comeback here. So in case you forgot, the repeat forever block will make the block inside of it repeat forever. Also introducing not just a wait until block, but something called an if then block. So this block is a C block. It says if, then it has a space for a Boolean, and then there's a space inside it. And this C block is going to let the robot decide what it's going to do. So it's only going to run the code inside if the Boolean block reports true. That means that whatever we put here, if that's not true, the robot says, no, I'm not going to do this. But if this is true, like for example, the robot detects the color that it's looking for, then it says, okay, yes, I am going to do this. So that's how the robot can make choices with these if-then blocks. Now the last new concept is not a block at all. It's an algorithm. So an algorithm is a set of very specific rules that you or a computer can follow to solve a problem. You probably learned some types of algorithms when you learned math. For example, if you're adding together large numbers and you have rules like now you need to carry the 1, that's an example of an algorithm. So let's try and build this algorithm. In order to do so, we need to delete the last program completely. So this program, you probably put some work into it, but it's all going away. Next, we need to answer the making rules section to build 3 rules. And then we're going to add all 3 of those rules to a forever block along with a drive forward block. Okay, let's figure out what that means. First question, this is an example. So this is based on the rules that I listed before. So what does the robot need to do when it sees a red disk? Well, the answer is right here. It needs to stop when it sees a red disk. And the way that we represent that in code blocks is with this if-then statement. So instead of analyzing this, I want to break it down in VEX Code VR. Here is our if-then statement. And just pay attention, there's also an if-then-else block. You don't want that one. We just want the if-then block. So what is it looking for? Well, it's looking for the color. So we can add the Boolean here. So make sure that it's front eye, just for consistency. Make sure that it's red, because that's what we're looking for. So this says, if it detects red, then what does the robot need to do? Well, the robot needs to stop driving. And that's rule number 1. So reading the whole thing, again, it says, if it detects red, then stop driving. So now let's take that same concept and think about green. So what does the robot need to do when it sees a green disk? Well, if you don't remember, you can go back up and look at the rules. It sees a green disk, it needs to turn right 90 degrees. Turn right 90 degrees. Now, how do we build this rule? Well, we're going to take our if-then statement. We add a Boolean to it for the front eye. And we switch this to if it detects green. And then you're going to put the blocks inside of it that make the robot turn right 90 degrees. Then you need to do the same thing for the last block, for the last color. This is going to be for blue. So if it detects blue, then you need to give it the command to turn whatever direction it's supposed to for blue. So go back and check the rules for that if you're not sure. Now, I think you guys can figure out how to build those 3 different rules here. So let's figure out what you need to do with that code. So it says add all 3 rules to a forever block along with a drive forward block. So the overall structure of your program, again, I'm leaving most things blank so you can figure them out here. but the end result is going to look something like this. Here's a forever block. Here's a plain dry for block. And then we have our 3 rules here. So if we think about this, our algorithm says robot's the default state. Like if nothing else is happening, just keep driving forward. But if you see red, then stop. If you see green, turn right. If you see blue, follow that rule too. So that's going to be the end result. And if you try this out, well, you might be surprised to see how far the robot gets through the maze. So that's going to be program 2. This is where the real hard work comes. Program 3, I want you to take program 2 and make it a little bit more complicated. So we're going to add 2 more rules. So first rule, instead of just driving forward, the robot should also start drawing. So before the forever block for program 3, I'm going to tell it to move robot pen down. Next, whenever the robot sees a disc, or whenever the robot sees a color, it should also change the pen to that color. So looking at it right now, we have this rule that says, if the robot sees green, it needs to turn right. We're going to add on to that, if the robot sees green, it needs to turn right and set the pen color to green. So you can run it again and see what exactly the robot does with that. It's basically going to be tracing its own path out. Should be pretty interesting to see. All right, engineers, so don't forget, if you need help, you can always email me or come to office hours at 1:30 every day. Now, I hope you guys have fun with this assignment. I'm looking forward to seeing the paths that the robot makes. That's it. Good luck on this. I'll see you next time.